Today, we're tackling a topic that's, well, not just interesting, but it's becoming really essential in our data-driven world. Data engineering. We've got some great source material here from Coursera, all focusing on the DeepLearning.ai data engineering professional certificate. So our mission really for this deep dive is to unpack all of that, try and get to grips with what data engineering is actually all about,
Mhm.
and see how a program like this helps you build the skills you need for, let's face it, a field that's in super high demand.
Absolutely. I mean, just think about it. Organizations everywhere, they're generating data at just an unbelievable rate. Raw data just flooding in.
Right.
But, raw data isn't really useful data by itself. Turning that huge amount of information into something valuable for businesses,
Yeah.
that's the trick.
Uh-huh.
Whether it's for, complex analytics or building machine learning models or even just helping make better day-to-day decisions, that's where data engineering really comes into play. It's the groundwork. It makes everything else possible.
So if you've ever sort of looked at the sheer amount of information companies are collecting and just wondered, how on earth do they even start to manage that?
Yeah.
Or maybe you're thinking about where the really critical tech roles are heading these days? Well, let's dive into what this certificate program covers and, what it teaches you about actually wrangling all that data.
Okay, so let's unpack this a bit. The source material, it kicks things off by defining the core idea. Data engineering is about turning that raw data into actual business value. But what does that really look like in practice?
Well, it means you're building and maintaining the systems, the plumbing, really, that handles data throughout its entire life cycle. I
Okay.
mean, organizations in pretty much every industry are just drowning in data, aren't they? Transaction logs, website clicks, sensor data, financial stuff, you name it.
Right.
And pretty much every team, marketing, finance, product development, they all want to use that data to
Yeah.
understand things better, optimize what they're doing, maybe innovate. And you can't just dump a messy pile of log files on a data scientist's desk and say, go figure it out.
Exactly. No, the data needs to be cleaned up, organized properly, moved around efficiently, and stored in a way that's actually accessible and reliable.
Makes sense.
So data engineering is that fundamental layer. It builds the pipelines, the storage systems, the whole architecture that makes sure the data's there, it's trustworthy, and it's ready for analytics or machine learning or, whatever else needs it downstream.
And because it's so fundamental.
Yeah, because it's so foundational to actually using data, the source highlights it as one of the highest demand jobs in tech right now. Companies are, frankly, desperate for people who can build and manage these critical systems.
Which leads us nicely into the program we're actually looking at today, the DeepLearning.ai Data Engineering Professional Certificate.
Right. So this one's offered by DeepLearning.ai, and it's in partnership with Amazon Web Services, AWS.
Okay, AWS. Good to know.
And the instructor leading it is a guy called Joe Reese. He's described as a top instructor, and maybe more importantly, he's the co-author of a book literally called Fundamentals of Data Engineering.
Wow. Okay, so you're learning from someone who actually, wrote the book on it.
Pretty much.
Yeah.
Seems like a solid source.
Yeah, that definitely sounds like a strong starting point. And the program itself, it's designed as this comprehensive online thing for people who are maybe already data engineers or perhaps practitioners in related fields, looking to shift into it or just, deepen their skills. The focus seems to be on foundational training, getting the core concepts down, the principles, and also gaining those practical hands-on skills.
Yeah, and what's kind of interesting is how they position the level. It's described as intermediate.
Oh, okay. Intermediate.
But, and this is important, don't let that word maybe scare you off if you're new to data engineering itself. The source clarifies it's aimed at, let's say, beginners in the field of data engineering.
Got it.
But you do need to come to the table with intermediate Python programming skills already. That's the prerequisite.
Okay. So a solid coding background in Python is necessary, but you don't need to be like a data pipeline expert from day one.
Exactly.
It also mentions that some basic familiarity with SQL, the database language, and maybe a little bit of AWS exposure is helpful, but they're not listed as strict requirements to get started.
Right. And looking at the logistics of it all, it's structured as a series of 4 courses.
4 courses. Okay.
They reckon it takes about 3 months to finish if you put in roughly 10 hours a week. But, like most of these online programs, it's built for flexibility. You learn at your own pace, it's all online, and it's taught in English.
All right. Let's get into the substance then. What do you actually learn? The program says it aims to help you build a really solid mental model for data engineering, like as a whole system.
Yes, exactly. And that mental model, it seems to be built around understanding the data engineering lifecycle and something they call its undercurrents.
Okay, life cycle and undercurrents. Let's break that down. The life cycle sounds like the journey of the data, right? They list 5 main stages. Generating the data in the first place, ingesting it, so getting it into your systems, storing it somewhere sensible, transforming it to make it useful, and finally serving it up so people or applications can actually use it. That seems to cover the whole flow.
It does. And then the undercurrents. These sound like the things you have to constantly think about across all those stages. Things like security, obviously.
Yeah.
That's crucial from start to finish.
Absolutely.
Then there's data ops, which is kind of like DevOps, but for data, bringing that engineering discipline, automation to data processes. Data management, ensuring quality, governance. Data architecture, the big picture blueprint.
Right.
Orchestration, which is about automating and scheduling all the tasks.
Right.
And just applying good software engineering principles to the code you write for data tasks. They're saying these aren't just nice to haves. If you neglect any of these undercurrents, your whole data system could fall apart.
That makes a lot of sense. It's not just about pushing data around, it's doing it reliably, securely, efficiently. The program also says it gives you a framework, a way to approach any data engineering project, whether it's big or small, always focused on creating actual business value, not just, building tech for tech's sake.
Right. Value is key.
And a big part of it is learning the principles of good data architecture, and this seems important, applying them hands-on using the AWS cloud platform.
Okay, so you understand the life cycle, you get the undercurrents. What about the specific concrete skills you walk away with?
The list they provide is pretty comprehensive. It covers concepts and specific tools.
Yeah, it looks like you learn about data processing generally, but then you dive into specific big data tools like Apache Spark and Apache Hadoop.
The big ones.
Yeah, these are key frameworks if you're dealing with truly massive data sets, spreading the work across lots of machines. You'll also really get into query languages like SQL for working with structured data. And you'll learn about essential orchestration tools like Apache Airflow. That's huge for scheduling, automating, and keeping an eye on complex data pipelines.
Okay.
And beyond just the tools, you gain skills in designing data architectures, techniques for data transformation, methods for data integration, like pulling data together from different places and understanding different data storage technologies, plus that crucial upfront work of requirements analysis.
Figuring out what the business actually needs.
Exactly. And the classic extract, transform, load process, or ETL.
Diving just a bit deeper into the skills list, the program seems to cover specific topics like data modeling, how you structure data for analysis. It mentions concepts like star schema, which is a really common way to organize data warehouses.
Those later stuff.
You learn about performance tuning, making your queries and pipelines run faster, implementing security controls across your systems, building reliable data pipelines. It covers data warehousing concepts, how to gather system requirements properly, and obviously working extensively with Amazon Web Services, AWS.
Yeah, the AWS part seems central. And you also get into more modern practices like infrastructure as code, ISC they call it.
Right, coding your infrastructure.
Exactly. Writing code to automatically set up and manage your cloud resources.
Yeah.
And applying CI/CD practices, continuous integration, continuous deployment to your data pipelines.
Okay.
They mentioned specific tools like Terraform for IAC and Amazon CloudWatch for monitoring.
Yeah.
Plus exploring different storage types like NoSQL databases, data lakes for raw data, and data lakehouses, which kind of blend lakes with more structure for easier querying. And specifically working with Amazon S3, which is AWS's big scalable cloud storage service.
Wow, that is a really solid list of skills. It seems to cover everything from the high-level design thinking down to the specific tools and technologies you'd actually use day to day, especially in a cloud environment like AWS.
And here's where it gets really practical and maybe exciting. The applied learning projects, they stress this isn't just watching lectures, you're actually building things.
Exactly. The source material highlights that a big chunk of the program involves practicing that really crucial real-world skill, taking kind of fuzzy needs from stakeholders.
Yeah, like I need to understand customer churn better.
Right.
Yeah.
Taking that and translating it into concrete technical system requirements, and then, importantly, choosing the right tools to actually build that system.
And you'll get hands-on experience by building actual pipelines on AWS, both batch pipelines, which process data in chunks, and streaming pipelines for real-time data.
Oh, cool.
The source even gives an example like maybe working on a product recommendation system, building something tangible that really mirrors a common real-world use case.
That sounds like a great way to see the whole life cycle connect. And you'll
Oh.
also apply those architecture principles we talked about, like assessing the systems you build on AWS for things like security, performance, reliability, scalability,
Mm.
and dealing with the, let's be honest, often messy reality of exploring different source systems and troubleshooting connection problems, which is a huge part of a data engineer's job.
Absolutely. You'll also use those modern tools we mentioned, like infrastructure as code and pipeline as code tools, probably Airflow again, for orchestrating, automating, and monitoring your data workflows.
Designing data lake and data lakehouse storage architectures is another hands-on task mentioned. Exploring how different storage choices affect query speed and, importantly, cost.
Right, cost is always a factor.
You'll practice modeling and transforming data specifically for analytics and ML use cases. They even mention comparing processing frameworks, like using single machine tools like Pandas versus the distributed power of Spark for bigger jobs.
That's a useful comparison.
And finally, you'll work on that serving layer, getting the cleaned, processed, modeled data out to the people or systems that need it downstream, like business analysts or machine learning models, completing that whole cycle.
Okay, so let's look quickly at how it's structured across the 4 courses they mentioned. Course 1 is Introduction to Data Engineering, estimated at about 17 hours. Sounds like it covers the life cycle, those undercurrents, gathering needs, and starting to think about designing and implementing pipelines on AWS.
Right, the foundation. Then, Course 2, Source Systems, Data Ingestion, and Pipelines, looks like the longest one, around 34 hours. This seems to be where you really get into the nitty-gritty of translating needs into actual implementation, building batch and streaming ingestion pipelines on AWS from different kinds of sources, and integrating all those undercurrents: security, data management, data ops, orchestration.
Course 3 is Data Storage and Queries, about 22 hours. Focus here is clearly on the storage layer, designing architectures, picking the right technologies, practicing different ways to query the data, and making those queries run faster.
And Course 4, Data Modeling, Transformation, and Serving, is around 32 hours. So this course takes the stored data, looks at how to model and transform it based on what's needed for analytics or ML, choosing the right tools, comparing distributed like Spark with non-distributed options, and finally focusing on serving that data effectively.
Okay, so pulling back a bit, who is this program really for? The source lists a few main groups.
Yeah, primarily it seems aimed at aspiring data engineers, people actively trying to break into the field, or practicing data engineers maybe looking to formalize their skills or learn cloud specifics.
Right, makes sense.
It's also suggested for data professionals who are currently in, let's say, adjacent roles, like software engineers, maybe data scientists or analytics pros who want to broaden their skill set or just get a deeper understanding of the data infrastructure side.
And understand the foundations better.
Exactly. And finally, they mention it could be relevant for data team leads or even technical business leaders who need a solid grasp of how these data systems are built and structured so they can make better strategic or technical decisions.
Okay, and what about certificates? You finish the program, what do you get?
Right, so if you're on a paid subscription or using financial aid and you complete all the graded assessments, you get a shareable certificate for each individual course you finish. They mentioned something about a 180-day eligibility period for these, though,
Okay, per course.
per course. And then if you successfully complete all 4 courses in the specialization, you earn an additional professional certificate that covers the entire program.
Ah, a main one for the whole thing.
Exactly. And these certificates, they're good for putting on your LinkedIn profile, adding to your resume or CV. It's a tangible way to show employers, hey, I've learned these skills, I've done this work.
Proof of completion.
The source also notes you can audit the courses for free, which means you can access the learning materials, watch the videos, read the content. But if you audit, you don't get access to the graded assessments and you don't earn the certificates.
Right, free access to learn, but no formal credential.
Exactly.
And just a few quick details about the Coursera platform itself, based on what's in the source. It's all online, obviously. You can access it through a web browser or their mobile app, which offers flexibility.
The pricing mentioned is a subscription model, currently listed at $49 per month.
Okay.
They offer a 7-day free trial when you subscribe, but it's important to know that there are apparently no refunds after that trial period ends, so you'd want to be sure within that week.
Good to know. They also mention other Coursera things like Coursera Plus, which gives unlimited access to a broader range of courses and online degrees. and Coursera for business for company training. But those seem like separate offerings, not part of this specific certificate subscription.
Right, different plans. And importantly, financial aid is available for this certificate program if the cost is a barrier.
That's good. Accessibility matters.
Oh, definitely. Okay, so bringing this all back to you, the listener, this whole deep dive into the program details, it really seems to emphasize the value here in providing both those essential foundational principles of data engineering and the really crucial practical hands-on skills you need to actually work in this field, which, as we've heard, is clearly in very, very high demand.
Yeah, it definitely highlights the flexibility too, learning at your own pace.
Yeah.
That makes it feasible to fit around an existing job or other commitments you might have.
And it repeatedly comes back to that core skill, doesn't it?
Yeah.
Taking real-world business needs, often kind of vague ones, and translating them into working technical solutions. That ability to bridge the business and the tech world seems key.
That translation piece is huge.
Wow, okay. That was a pretty comprehensive look at what this certificate program offers. It really does seem to map out that entire journey data takes and all the engineering needed to actually make it useful.
It really does. It shows the sheer breadth of skills you need. It's so much more than just writing code, isn't it?
Yeah.
It's about architecture, thinking about the business value, baking in security and reliability, and knowing how to work effectively with modern cloud platforms like AWS.
Absolutely. And given that the sheer volume of data in the world is just, well, it's exploding, right? The need for skilled people who can build and maintain these absolutely vital systems, that's not going away anytime soon. It's only going to grow.
For sure.
So for you listening, as you think about this whole flow of data, starting from messy, raw generation all the way to being polished and ready for powerful analytics or machine learning, here's maybe a thought to leave you with. In a world that's just awash with data, how much of it do you think is actually being effectively harnessed to create real value today? And what specific challenges or opportunities within that whole data engineering process do you personally find most interesting or most important for the future?
That's a really important question to ponder. Because unlocking the potential that's sitting dormant in all of that data, that's really key to future innovation, isn't it? And data engineers, well,